All right, so today we're going to continue on with 4.3, which is called rational thinking. And here's our task for today. Our job for today is to go look for patterns so that we can fill out this chart. We're looking at how to find vertical asymptotes, horizontal asymptotes, and intercepts. We're wondering if the degree of the numerator is less than the degree of the denominator. What does that imply for us? And what if the degree of the numerator is greater than the degree of, or equal to, sorry, my bad, equal to the degree of the denominator? And so based on those two thoughts, that's going to help me understand how to find my vertical asymptote and my horizontal asymptotes, okay? So the first things first, hold on a second, let me open up one more thing. Where'd it go? It's over here. Okay, so the first thing, you're given several different functions. Start by identifying the degree and of the numerator and denominator. So let's do that first. So over here, I want you to look at the degree of the numerator and denominator. That's actually asking you this. What's the highest power of x? What's the highest power of x? Go ahead and fill that out. What's the highest power of x in the numerator? What's the highest power of x in the denominator? Oops. All right. Giving you a couple more seconds. So hopefully you said the degree of the numerator is 1 because it's x to the first right here. Everybody comfortable with that? This is a 1 right here. Questions on that? Very good. Very good, very good. All right. So the next part is what's the degree of the denominator? And you guys are like, oh, I get it. Okay, so this is going to be 1. Got it? So everybody okay with this so far? Everybody's okay with this so far. Okay, just for fun, let's skip over here. Can you fill out the degree of the numerator and the degree of the denominator? Can you fill out the degree of the numerator and the degree of the denominator? All right, what do you guys think? Numerator, 1, very good. Denominator, don't get tricked. Don't get tricked. Yes, it's a 2. Some people are like, Ms. Johnson, it's a 1. Look, they both are 1s. Yes, but x times x is x squared, right? X times x is x squared. So everybody comfortable with this first part? Any questions on numerator, denominator, degrees? Any questions on this first part? Okay, so then let's go back to our directions. Where are they? Here. Okay, then it says, as you are working, look for patterns that'll help you complete the table. You need to find a quick way to identify the horizontal and vertical asymptotes when you see the equation of a rational function, as well as noticing other patterns that'll help you analyze the graph and the function quickly. The last 2 graphs are there so that you can experiment with your own rational functions and test your theories. Yes, numerator is the top and denominator is the bottom. I say numerator is the top and denominator is down. DD, right? Has some alliteration for you. Okay. So what I want you to work on today is something that a calculator can't do. Now, look, some of you are like, Ms. Johnson, yes, it can. Look, the calculator can totally do this. And you're right. X plus 3 parentheses divided by x minus 2. Right? Yes, Ms. Johnson puts parentheses on the top just so that Desmos knows that I want that to be as the whole numerator. So if you actually look at this, you can kind of see where my vertical asymptote, it looks like it's right here at 2, and my horizontal asymptote is here at 1. So this is something that we already talked about. So here, this is horizontal is y equals 1. And then vertical asymptote is x equals 2. Okay. So your job is to look at this thing and be like, okay, well, where is the x is equal to 2? Where is the 1? Anybody see any pattern so far in terms of our horizontal or vertical asymptote? Does anybody see our patterns in terms of our horizontal or vertical asymptotes? Yeah, the vertical asymptote kind of reminds me of the denominator, which is exactly correct, right? And that makes sense because what's the purpose of our vertical asymptote? The vertical asymptote's purpose. Anybody remember this? What is the purpose of our vertical asymptote? Like, why does he exist? So yeah, he's the movement. He moved to the right or to the left. Very good. But why does the vertical asymptote even exist? Like, why can I draw? Sorry, let me ask. Annotate on top of my screen. Let's see. Let's use like an orange color. Like, why can I draw this dashed line down here? Like, why can't, I'll give you a clue. Why can't our function live on our vertical asymptote? Why can't our vertical asymptote, or why can't our function live on top of our vertical asymptote? So here's what the calculator can't do. I say, hey, graphing calculator, Desmos, Miss Johnson's best friend. Why can't why do you have a vertical asymptote at 2? Do you see how the Desmos is not answering me? So that's the power of Desmos. The power of Desmos is it's going to graph it for me. The power of you as the human who can analyze things, you're going to ask the question, well, why can't it? Why is there a asymptote right here? And so you guys that's what I'm teaching you all to do, is preparing you to stand out, right? Above computers and your peers, right? So yeah, so why do we have vertical asymptotes again? Because they can intersect, kind of, but no, not really. I know, Miss Johnson. Why don't I just plug 2 in? What happens if I plug 2 in, guys? Here, here. What happens if I plug 2 in? Come on, y'all. Get in there and answer. Be uncomfortable. Yeah, it's undefined. Oh, okay. What is so important about undefined? If you can answer, oh, Ms. Johnson, I understand, then you understand rational functions, because that's what makes rational functions, is the fact that there are certain parts that they can't be defined at, hence our vertical asymptote. So do you all know what we mean by undefined here? Is everybody comfortable with that? If not, here you go. Copy this, paste it here. I'm going to put 2's in for everything here. Here. Oh, it's undefined. Right? Why is it undefined? Yeah. We can't have 0 in the denominator because we can't divide by 0. We can't have 0 in the denominator because we can't divide by 0. Okay, does that make sense? That's the biggest part about rational functions you need to know. So somewhere in here, I'm going to get an undefined number. What numbers make it undefined defines part of your rational function. I'm going to say that again. Because this is a rational function, I know that there's some numbers I can't plug in because it'll make my function undefined. What numbers make it undefined help create my rational function. In this case, it's x is equal to 2. Okay, good. Now, does anybody see this 1? Does anybody see a 1 here? And you should say there's a bunch of 1s there, Miss Johnson. I don't know which one. So in case you don't know, there's a 1 right here. There's a 1 up here. There's a 1 right here. There's a 1 right here. Right? There's a bunch of 1s everywhere. So your job is like, I wonder which one, just kidding. I wonder which one makes it the horizontal asymptote of 1. Do y'all see this? Yes, okay. Okay, last but not least, I need my intercepts. So I'm just gonna plug right here. And it looks like it's -3, 0 and 0, -5. So I'm gonna write that down. -3, 0. Why am I writing it like this? Why am I not? It's so funny. and 0, negative 1.5. Negative 1.5 makes complete sense to me, because if I plug in 0 here and 0 here, I'm left with 0 plus 3, which is 3. 0 minus 2 is negative 2. 3 divided by negative 2 is negative 1.5. Makes sense, right? Your job is also to make sense of things. So this is what a graphing calculator can't do. I can't say, hey, Desmos, why does this make sense? Why does this answer make sense? Right? So that's pretty huge there. Everybody okay with me so far? So good? Okay. I want you to go to this one now, and I want you to find just the vertical asymptote. Okay. And I'll give you a hint for this one. I need you to find the vertical asymptotes. I need you to find the vertical asymptotes. Ignore horizontal asymptote right now, because we're still unsure. If you want to guess about it, go ahead and guess about it. But right now, I just want you to find the vertical asymptotes and guess what the horizontal asymptote is. Very good. I'm going to pause it and let you guys work for just a second. Okay, so we're back, and there's a bunch of you who figured out some stuff. I love when you guys guess things and then you're wrong. I know that sounds really mean, but when you try something and you're wrong, and then you reflect back like, okay, well, why did I do that wrong? Right? Hopefully you are at the point where you're comfortable and you're like, oh, that makes so much sense. So when it's not a big deal to make mistakes in math, and actually you should be making mistakes in math. And if you're not making mistakes, it's because you're not taking enough risks. You're not trying, right? And if you're not trying, you're under the misguided belief, right, that you understand what is happening by watching me do it, by watching us do it together. Okay. So some of you did your vertical asymptotes. I wanted to do it on here just so that you guys can all see my math. So how did you guys do your vertical asymptotes? What did you do first? We already know this is a 1, this is a 2. How did you guys find your your vertical asymptotes? What did you do? Yeah, you looked at the denominator. Okay, fine. I look at the denominator, and then what do I do? Yeah, make it equal to 0. Why are you setting your denominator equal to 0 when you just told me when I divide by 0, it makes it undefined? Doesn't that feel weird? Why do you take your denominator and set it equal to 0 when you all just told me that when uh-oh, what just happened? Something just happened. It all went away. I'm in the wrong spot. I think I'm in the wrong spot. That's why. Haha. There it is. Okay. So why would you tell me to do that? You just told me that dividing by 0 makes it undefined. Why would you set the denominator equal to 0? Because that's actually what you're trying to find. You're trying to find, when does my function go undefined? And so you take your denominator, you set it equals 0. Anybody remember how to solve this? Yeah, you just take each of them equal to 0. So that's x plus 2 equals to 0. X minus 3 equals to 0. So x equals negative 2 and 3. Everybody okay with this? Yeah, exactly. So then if I was graphing this on a graph, right? Let me just like this. Oops, it got a little crookedy. Sorry, got a little crookedy. My iPad moved. Okay, so then I would take these two, x equals negative 2, x equals to 3, and I would graph them, right? So x equals to negative 2 looks like this, dot, dot, dot. On your graphs, if you ever have to graph this, asymptotes tend to be dashed lines because they're not actually part of your graph. They help you graph. Does that make sense? So that's why I make them as dashed lines. So x is equal to 3 looks like this, dash, 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 dash. Good. Okay, so there's my my 2 vertical asymptotes. And this is the first one that we've ever seen with 2 vertical asymptotes. Doesn't it make sense for us to have 2 vertical asymptotes? Doesn't that make sense? Yeah, because there's two different numbers that'll make my function undefined. So that means I got to go here. Ms. Johnson, can you have more than two? Anyone want to answer that question? Can you have more than two vertical asymptotes? Someone say, yeah. In fact, you guys are going to learn a function later on that when you graph it, it actually has an infinite number of vertical asymptotes. And you're like, Ms. Johnson, are you going to make us graph all those? I literally cannot, because to graph something that goes on infinitely would mean that you would be drawing it forever. So I know Ms. Johnson, you think she would make you do it, but no, she doesn't. Okay. So you can tell that there's like three little sections of your asymptote or your graph. There's this part to the left, there's this section in the middle, and then there's this section to the right. I wonder what it's going to look like. That's what your brain should be saying. Okay. In terms of horizontal asymptote, did anybody guess at your horizontal asymptote? Did anybody guess? Like, Ms. Johnson, I think it's this. Someone said 0. Okay. Anybody else? 0. Okay, good. So I'm going to just go back to our graphing calculator here and actually graph it and see if this is what you guys thought it would be. Okay. So here's x plus 2, close open, x minus 3. Is this what you thought it would be? Did you foresee these three, I'm still going to call them branches, these three branches? And someone's like, the three branches make sense, Ms. Johnson, right? Because you gave us two vertical asymptotes, so there was three sections. I was curious as to what would happen in between. Ms. Johnson, this one looks really weird. I know, right? So some of you are like, Ms. Johnson, I don't really see an asymptote. Yeah, you do, right? There's an asymptote right here, right? And some of you are like, but Ms. Johnson, you said an asymptote means it gets closer, but never touches it. That is always true for a vertical asymptote. That's not necessarily true for our horizontal, specifically because something happens. I don't know how to better say this, but inside two vertical asymptotes, it's almost like protected, if you want to think about it. So that you guys were right. It is a vertical asymptote of horizontal asymptote of y equals to 0. So go ahead and write that. From here, you can actually see your intercepts at 0, 0. So some of you are thinking, Ms. Johnson, without this graphing calculator, how would you be able to know where these are? So that's a really good question. And because we have access to a graphing calculator, you don't necessarily have to think about it. But I will show you back in the day, and this is like in my day, what you would have to do, or actually you tell me, what would you have to do next if this was without a graphing calculator? What would you do next to figure out where it lives? What would you have to do? What would you have to do in order to do this? If I wanted to know where the graph is, what would you do next? Yeah, just start plugging in values of x. All right, someone give me a good value of x to plug in. Anybody know my favorite number to plug in? What's my favorite number to plug in? Yeah, it's 0. 0 is my favorite. Ms. Shelton, why is 0 my favorite? Because everything goes away, right? Watch, do it with me. 0. Now I just need to make sure this bottom isn't 0, and then we're good, right? 0 divided by 0 plus 2, which is 2, and 0 minus 3, that's -3. So that's 0 divided by -6 is 0. So I'd be like, yeah, so this is where one of my points is, 0, 0, which tells me that's my intercept. So we're good on that, right? I forgot to write my horizontal asymptote equals to 0. So I should use a different color for this just so I can color code my graph. So here's my, you guys are like, Ms. Johnson, that bugs me because that point is on a horizontal asymptote. Yeah. So he's like in between these two vertical asymptotes. So something happens. It's the best way for me to describe it. Will it always be possible to plug in 0? Yes. Will it always give you a point? No. Right? Can I always plug in 0, Ms. Johnson? Yes. Plug it in. Figure out what happens at it. Okay, so I'm plugging in 0. I get that. And I'm like, oh, I can't see what the picture is. This is almost like connect the dots, right? And you don't know what the picture is, and you have one dot. you have no idea what the picture is, except for we do because we just graphed it, right? So you need to plug in more points. So then I would plug in 1. So then I get 1 divided by 3 times -2. So that's 1 divided by -6. Is that what I got? Yeah, -6. So I got -1/6. So like imagine Miss Johnson really can graph very precisely. So she put this little dot right there at -1/6. And then I plug in 2. 2 divided by 4, -1. So that's -1/2. So then it's like here-ish. They're like, great, Miss Johnson, this is not a picture. It's a cat. It's a dog. It's Superman. Who knows? So then you're just plugging in numbers to kind of get a feel for where it is. I'd also plug in -1. I'd probably get something up here. And so your curve ends up being like this, right? And then we already know that it went like this and it went like this. So you would just plug in a bunch of points until you got this graph. Does that make sense? All your job is to figure out where it's living. Now, does this make sense? Now, some people are like, Ms. Johnson, this kind of doesn't make sense. Like, I still don't get where the horizontal asymptote is. I don't see a 0 anywhere here, Miss Johnson. You're right. You don't, right? So again, we're pretty strong on our vertical asymptote, right? How do you find your vertical asymptote? How do you find your vertical asymptote for number 3, for number 4, for number 5, for number 6, for those ones, right? How are you going to find your vertical asymptote every single time? Yeah, you're going to use the denominator, right? So you should write yourself a note right here. I don't know, to find the vertical asymptote, the VA, right? I can't type, have to look at the blank, right? So make sure you guys are comfortable with this because I'm going to ask you, hey, how do you find the guaranteed question on the test, right? What are your steps to finding the vertical asymptote of a rational function? And you're like, boom. So what are the steps? How do you find your vertical asymptote? Someone said the denominator. Can you guys chat publicly so you guys can all see your answers so you all don't think Miss Johnson is talking to herself? Very good. Someone says, look at the denominator and set it equal to 0. Boom. Someone else, oh, man, you too, like almost said the exact same things. That was awesome. Right? That was awesome. All right, I'm snipping this. I'm going to put this as part of our notes. I just chose a random person. However you understand it, that's how you should write it, right? Let's see. I'm going to put this right here with this so that you guys all know to find the VA, I have to, but so look at the denominator and set it equal to 0. Very good. Which sounds really weird, right? It's really backwards to think. In order for me to find the vertical asymptote, I have to set the denominator equal to 0, which you told me that we can't divide by 0. Exactly. So if I can find the places where my function is undefined, it helps me graph it. Okay. Again, we're still really curious about this horizontal asymptote business because gosh, he's not like over here, up here, it was 1. Down here, it is 0. Okay, wait, let's go back here. So here you can kind of fill stuff out, right? How do you find the vertical asymptote? Right? And some of you can already put this here, right? Ooh, does that work? Sorry, we're going to squish this. We're squishing it. Okay. And Ms. Johnson, what is that for? Is that for the top or for the bottom? It's for both. So you just want me to look at the denominator and set it equal to 0 both times? Yes. The horizontal asymptote, man, he's weird. If the numerator is less than the denominator, if the numerator is less than the denominator in terms of the degrees, that's a different case than the numerator being equal to the denominator. Okay, wait. So these degrees were equal. And our horizontal asymptote was what? Oh, y equals 1. And these degrees are different. and our horizontal asymptote was 0. Okay. I still feel like I don't have enough information. I already know the answer, by the way, in case some of you are like, does she not know what she's doing? I know what I'm doing. I'm just trying to get your brain to be curious with me. Okay, so here's what we're going to do. You're going to try to do this one right here. You're going to do this one. You're not going to try. You're going to get this one done. I want the degree of the numerator, the degree of the denominator. I want you to find the vertical asymptote without using the graph. And then I want you to use the graph to find your horizontal asymptote. Okay. Someone asked earlier, Ms. Johnson, this one only has one asymptote? Yes. I mean, sorry, intercept. This one only has one intercept? Yes. Right? And that intercept happens to be both the X and the Y intercept. Okay. So right now I'm going to pause the video. I'm going to have you guys do this part right here. Yes, yes, yes. I need you to work on this. The more you practice, the easier this becomes. So practice now. So what do you guys think? In terms of finding the numerator and the denominator, you guys figured this out, right? What is the degree of the numerator? This one I thought was interesting. What's the degree of the numerator for this one? Yeah, it's a 0. Jonathan, why is it a 0? Because there's no x's, right? What's the degree of the denominator according to this? Yeah, it's squared. Very good. So the horizontal asymptote, I'm going to skip for now. The vertical asymptote for here, you guys told me up here, look at the denominator and set it equal to 0. Okay, so x plus 4 quantity squared equals to 0. So let me do that. X plus 4 quantity squared equals to 0. How do you solve this thing? What's the first step? What is your first step? What is your first step? Yeah, square root it, right? So when I square root it, what does Miss Johnson always say? Don't forget the plus or minus. Very good, very good. And then so what's left over is x plus 4 equals to plus or minus the square root of 0. Okay, first of all, what's the square root of 0? What's the square root of 0, y'all? Yeah, it's 0, right? So I don't need a plus or minus because 0 is not plus or minus. He's my neutral guy. He's the only number that's neither positive nor negative, right? So I just leave him as 0. So I understand why some of you thought that the answer was going to be 4 and -4. Not in this case, right? The square root of 0 is 0. Okay, so then what do? So then I subtract 4. So I get answer is x is equal to -4. My vertical asymptote is x is equal to -4. You could imagine yourself, right? Here's my axes. Boom, boom. And then my asymptote. That was funny. I was listening to your guys' flip grids, and some of you, I could tell how much you listen to me because you say goofy things like I say. Like I say asymptote because that's how it helps my brain remember how to actually spell it. Because that P is silent, right? You don't say asymptote, right? You just say asymptote. So my brain uses weird things like that. And so I heard one of you say that and kind of made me smile because I was like, I can tell that she listens to me, right? All right, so x is equal to -4. There's my asymptote, boom, right? They want you to find the intercepts because they want you to look for where it is on the graph. So I'm going to do that. So in case you don't know how to find intercepts, it just goes like this. You fill in these points like this, 0, comma, what, and what, comma, 0. And sometimes those 2 points are the same and it's 0, comma, 0. And sometimes they're not. They look like, oh, I didn't write it down here, but you guys all get what I'm saying. So I'm going to plug in 0 to my function and see what I get out. So I get 1 divided by 0 plus 4 is 4 squared is 16. So I get 0, comma 1/16. 1/16, right? So that's like, this is going to look really funny, but it's going to almost look like it's right on top of 0, comma 0, right? He's right there. You can barely see him. And then I'm going to say, hey, when does this equal to 0? Okay, and I haven't necessarily taught you how to solve these, but can you think of a number? Okay, just go walk down this road with me. Can you think of a number that would make this equal to 0? Can you think of a number that would make this whole thing equal to 0? Right? So this one makes sense. It would be 0. because if the numerator is 0 and the denominator is not, then it's 0, right? But this one doesn't really make sense because some of you are saying, oh, -4, Miss Johnson, but -4 plus 4 makes it 0, 0 squared, and then 1 divided by 0. You got your head should have like these little alarms blaring, like, like you shouldn't be able to do this, right? So there is actually no number that would make this equal to 0. So let me say this again. There's no number that would make this equal to 0. So therefore, I do not have an x-intercept, right? So tell yourself why really quick, because these are, again, the important parts. Tell yourself why you know that you do not have an x-intercept. Why don't you have an x-intercept? Look at this right here. What number can I plug into x that would make this equal to 0? Okay, I'll walk down this road one more time. In terms of fractions, when you're trying to make something equal to 0, you really just care about the numerator, because 0 divided by anything is 0, except for 0, right? So, but this is a 1. They're basically asking you, hey, when is 1 equal to 0? Right? It doesn't exist. Everybody with me on this? You guys okay? Does this make sense? Okay. Can you write yourself a little note to yourself? Hey, this is the reason why I don't have an x-intercept. Write it to yourself so you'll remember later. Okay, so then I'm going to jump back over here and I'm going to look for my horizontal asymptote. I'm going to graph it. So 1 divided by x plus 4 quantity squared. This one's weird looking, Miss Johnson, isn't it? It's weird looking, right? It's weird looking. Okay, so I definitely see my -4 vertical asymptote. Do you guys all see your horizontal asymptote? What is your horizontal asymptote? It's 0. And it makes sense, right? Because of what you just told yourself. My horizontal asymptote is going to be y equals to 0 because of what we just talked about, right? There's no number that I can think of that would make that equal to 0. You can't see my vertical asymptote. He's there. I tried to dot him in slightly. So, Ms. Johnson, why are both of the branches up top? Did anybody think about that? Hey, Ms. Johnson, why are both of the branches up top? Why are both of the branches up top? Anybody can look at this thing here. Why would both of your branches be on top? Anyone want to take a guess? What is different? Yeah, because it's squared. Good job. Nice risk taking there. Yeah, because it's squared. This squared made it go on top. Oh, Miss Johnson, this one was kind of alternating, right? On top, everywhere on the bottom. Why is that one though, Miss Johnson? Because of the top, right? This one made both of them go on top, but this one made it alternate top and bottom, right? This one too. Okay, moving on, Miss Johnson. Okay, so here's what I want to say, and I want to make sure that we get our takeaways in. I would like you to practice number 4 on your own, looking at your horizontal asymptote. Number 5 on your own, looking at the horizontal asymptote. You guys know how to do all of this except for the horizontal asymptote. So that's what I want to focus for this last little bit of class before I let you guys leave. So yes, please make sure that you can do this one and this one and this one and this one and this one. There's a lot of them. These ones are the ones that you guys are trying on your own. So let's talk about takeaways before we go, just to make sure that we are comfortable with our takeaways, okay? So it says, you guys were right. Find the roots of the denominator. That was right. Check and check, right? You guys got this? Yeah, you guys got this. Now, some people guessed this and I was like, woo, we figured it out. Okay. So some of you figured out that it's always going to be y equals to 0 when the numerator is littler than the denominator. So I talked about it as who wins. Okay. So if the denominator's degree wins, your asymptote is y equals to 0. You're not finding anything. It's just boom, y equals to 0. Wait, like what, Miss Johnson? Like this one. Like, does everybody see how the denominator's degree wins? Does everybody see how the denominator's degree wins on this one? Yes? Yeah, it's squared. So what was our asymptote? Y equals to 0. Okay, you guys go up here. Who won here? Numerator or denominator? Who won here? Numerator, denominator? You guys are like, denominator, exactly. So if the denominator wins, our asymptote is always y equals to 0. Y equals to 0. Okay, and then I have to go back here because I didn't take notes on my notebook. I think we were here. No, we were here. Yes, number 1, right? If you look at this one, the denominator didn't win. That's why our asymptote is not 0. Okay, Miss Johnson, then what is it? If the numerator and the denominator are tied, if the numerator and the denominator are tied, you take the leading coefficient divided by the leading coefficient. Huh? You take the leading coefficient and you divide it by the leading coefficient. Okay, let's look at this one. The leading coefficient is 1. Remember we said there's all of these ones. Here's the ones that you'll use. You take the leading coefficient, the number in front of your highest power, and the number in front of highest power, and you divide. 1 divided by 1 is 1. Okay, let's try another one, just making sure. So here, go to slide 12. So numerator, degree of numerator, it's 1. Degree of denominator, it's 1. Miss Johnson, they're tied. Good, then you look in front. When you look in front, we take the numerator leading coefficient and the denominator leading coefficient, and we divide. What's our horizontal asymptote for this one? Someone says what? Y equals to what? Come on, before the calculator. Do it before the calculator. Do it before the calculator. Uh-oh, you guys don't know this. What's 3 divided by 1, y'all? Yeah, it's 3. Okay, if you're right, then I'm going to be able to plug it in here and I'll get it right. Is that horizontal asymptote the what you thought it would be? You're like, Ms. Johnson, I can't really tell. So zoom out a little bit. And you're like, yeah, it's right there. Okay, now zoom in a little bit. So it's right here. Sorry. It's right here. It's below, this is counting by 2s, right? 2, 4. It's below 4 and above 2. Who is below 4 and above 2? Oh, it's 3. Okay, so this chart is going to be your best friend in terms of this homework. Okay, there you go. Here, you guys already knew this. We didn't need to go over this. So just making sure. So let's test ourselves right now. Everyone, close your eyes because you can see the chart because it's right in front of you. Tell yourself how you find the vertical asymptote. Tell yourself right now. How do you find the vertical asymptote? All right, someone hopefully said you set the denominator equal to 0 and then you solve it. Another way to say that, and this is what this chart says, is find the roots or the solutions of the denominator. Okay. Okay. How do you find the horizontal asymptote? And you should say, wait, Ms. Johnson, it depends, right? If the denominator wins, it's automatically what? If the denominator wins, it's automatically what? Last but not least, if the denominator and the numerator are tied, you look to your coefficients and divide, right? Just like we did in this one. Is it this one? Yes, in this one, right? We looked here. So we looked at 3, we looked at 1, we divided 3 by 1, and then we got that. Okay, so that's what you're supposed to do. Really good job listening. I appreciate you all greatly.